break a number like 12 into 2 times 6 or 3 times 4. You can program a computer to do this, and if the numbers aren't too big, computers can do this pretty quickly. But traditional computers attack problems like this, one step at a time. So as the numbers get bigger and bigger, it takes longer and longer. Factoring numbers is at the heart of almost every secure transaction on the internet today. Passwords and sensitive information are encrypted using algorithms that rely on the fact that factoring very large numbers can take years for traditional computers. But what if we had a way to factor a number almost instantaneously? What if we could factor a number in basically one step instead of many? The secure internet as we know it would fall apart, and quantum computers could be the reason. You might have heard of binary before. A traditional computer stores and processes information using ones and zeros. Each one or zero is called a bit. Whenever you do anything on a computer, on the inside, it takes a big list of bits as inputs and spits out another list as outputs. Microscopic on and off switches called transistors store the bits in your computer, and the best home computers today have a few billion transistors inside. And this ushers in quantum computers. A quantum computer with only about 30 quantum bits or qubits can in principle hold as much information as about 1 billion regular bits. How, you might ask? This is where it gets weird. Qubits are made of things like electrons, which, as you might know, are extremely small. The world of the small is nothing like the world as we know it. For example, when we observe an electron, we always find it has one of only two types of spin. But the theory of quantum physics says that before we measure it, it has both spins at the same time. A group of electrons can be formed in a way so that all the electron spins are inextricably linked in what creates a massive network of information. It's like the cloud of electrons is students at a school, and it has all the information about who is friends with who and how each group at the school interacts. If you are an introvert like me, you are unlike the cloud of electrons, knowing nobody and knowing nothing. In the quantum world, these relationships are called entanglements. No, not like Will and Jada, but this entanglement means that a quantum computer built out of a small network of qubits can store and process huge amounts of information, but it's not without challenges. Building networks of qubits is physically difficult, and I won't go into details, but when you try to get information out of the qubits, quantum rules say you literally can change the system altogether. Quantum computing is still very much in its infancy. There are real hurdles to overcome before it takes off, but the good news is that quantum computing won't only be good for breaking encryption, it can potentially improve encryption and revolutionize fields like drug development, artificial intelligence, and climate modeling. Google and others have made huge advances, and it's something to watch out for in the near future.